Hello, students. I apologize for not being at school today. My daughter is sick, so I'm at home with her. Um, and I hope that you have a good day. If there's any questions on any of this, please know that I'll make time tomorrow to talk about any of this. But I do think that this is a lesson that should be mostly review from last year. We just need to talk through a few things. So this is our first official lesson in chapter 4, where we're going to be talking about area of parallelograms. And as we talked about yesterday, that includes rectangles and squares. They all fall under that umbrella of being parallelograms. But because they are slightly different, we're going to find their areas a little bit differently. So when we talk about area, we remember that this is the amount of surface a shape covers. So for example, if you are talking about carpeting a room, that is finding the area. You're covering that whole floor space. If you're talking about painting one wall, you're covering that whole wall. If you're talking about the grass, if we were put lay down a football field, that's all area. You're covering a surface. And so we're trying to figure out how much that is. And so when we do that, we measure area in what are called square units. So depending on how it is labeled, we might label this as miles squared, inches squared, centimeters squared. It just depends on the dimensions of the shape we're talking about. We just take whatever those dimensions are and we're going to put a little 2 next to it to show that's a square unit. Okay, so the first thing we want to talk about is parallelograms. Okay, we talked yesterday about the characteristics of a parallelogram. That it does have this sort of slant to it, although it doesn't have to. That's what, we said a rectangle is an example of a parallelogram. It doesn't have to have that slant, but it's important that we recognize when a parallelogram does have a slant, because that makes the dimensions not more challenging, not difficult, but we need to pay more attention. So when we talk about the area of a parallelogram, you'll see underneath the picture that the formula for area of a parallelogram, when I talk about formula, it sounds a lot like algebra. We're going to be using letters and then changing them to numbers. So formula is just a fancy way of saying, hey, this is an algebraic problem, but it really means something. It's going to tell us something about this geometric figure. So the formula here is area equals B times H. We see them squished together there, meaning multiplication. And so underneath, I wrote that B represents the base and H represents the height. So in the last chapter, I would give you letters like X and Y, or even B and H, and then I'd have to tell you, okay, X equals 4 or Y equals 9. But in this chapter, I'm not going to give you that information. We're going to have to look at the shape and find, hey, where is the base? Where is the height? And then we'll substitute that in and evaluate this expression. So we have to learn how to look at a picture and pick out all this information. So in a parallelogram, the base is pretty easy. Base kind of reminds us of the bottom or the basement of a house. So the base is going to be the bottom of our parallelogram. So go ahead and label this the base. Now you'll notice that the base isn't labeled in this picture, but we can find that it is 7 inches long because, as we talked about yesterday, the sides of a parallelogram, opposite sides are congruent. So if we are pointing at the base, that should be the same length as the side opposite it. So really we could call both of those sides bases, okay? Now the other dimension we need to know is the height. And so we see that a dotted line has been added into this parallelogram and labeled with 4 units. We call this the height. Go ahead and label that. Now, this is important to talk about. When you go to the doctor's office and they want to know how much you've grown and they ask you to give your height, you're going to stand up against that wall and they bring that little measuring thing down and they're figuring out your height. You, of course, want to stand up nice and tall. A parallelogram is the same. When we talk about the height of a parallelogram, we need a dimension that is nice and straight, that meets the base at a right angle. So in a parallelogram, we talked about the angles aren't necessarily right angles. In fact, probably a lot of the times they won't be. So the side of the parallelogram is actually 5 units long, but because it doesn't meet the base at a right angle, we can't use that 5. That's like going to the doctor's office and slouching over when they're taking your height. We can't use that. We need to add in a line, and that line is going to meet the base at this nice 90-degree angle. So it's perfect. It's nice and straight, just like when you're at the doctor's office. And so we call that the height. This is important to recognize because a lot of times in parallelogram problems, they're going to give you that extra piece of information because they're describing the parallelogram to you. But that 5 is useless to us. We don't need it at all. Okay. So area of a parallelogram is base times height. Turn to your neighbor and repeat that formula to them. Area equals base times height. Okay, the next shape we want to talk about is the rectangle. Okay, remember a rectangle is a type of parallelogram. So if you were to totally forget the rectangle's formula, we could use the same exact formula as a parallelogram. It works here too. But in a rectangle, this one is more unique because the sides do meet at right angles. So we don't need to add in a height. We already have 2 dimensions that meet at that right angle. So if you look underneath the picture, the formula has changed. The area equals L times W. Again, squished together because they mean multiplication. Please, please, please recognize that is an L, not a 1. Okay, L times W. So underneath that, I wrote L represents the length of that rectangle. And length is going to go from left to right. And I like to kind of remember length starts with L. So that should help you remember left to right. They both start with L. Okay, so if we go up to the picture, the length in that rectangle, of course, would be the 20 centimeters. So let's label that. Okay, and then the width is going to be the up and down portion of that rectangle. So in this case, it is the 8 centimeters. So we'll label that the width. Okay, so when we go to find the area of a rectangle, like I said, we don't need to add in any dotted lines. We don't need to have a height. They already meet at a nice right angle. And so we have our length and our width. We multiply together to find area. So I need you to turn to a neighbor, tell them the formula for area of a rectangle is length times width. Now turn to your neighbor and tell them the formula for a parallelogram. Okay, let's look at the last shape, which is a square. Now, again, a square is technically a parallelogram, so you could still use area equals base times height. A square is also a rectangle, so you could use area equals length times width. But because a square is unique and it has all 4 sides are the same, then we have a special formula for square, and that is area equals S squared. Okay, that's where squared comes from, by the way. Squared for a square. So when we look underneath that, S represents the sides of the square. And remember, all the sides are the same. So usually in a square, they're really only going to label one side so that you can assume, okay, if this is 11 centimeters, then all 4 sides are 11 centimeters. Now be careful. Don't use your eyeballs to decide if something is a square or not. Look at the dimensions, pay attention, see, is it really a square? If they only gave you one dimension, you can safely assume it's a square. But if they gave you more than one dimension, you better check and make sure, is this truly a square? So when we go to label the sides, obviously both of these boxes would be labeled as a side. So I would like you to turn to your neighbor now and tell them the formula for area of a square is area equals side squared. Now turn to your neighbor and tell them the formula for area of a parallelogram. And now tell them the formula for area of a rectangle. Okay, it is my expectation that at the end of this unit, you will have these formulas memorized. So maybe you need to make flashcards, maybe you need to, make a Quizlet, whatever you need to do to memorize these 3 formulas. And we will add another formula tomorrow. So please, please, please be working on that. All right, so why don't we pause the video here? If you have any questions, talk through as a class. If you don't know those formulas, if you just want to practice saying them to a neighbor, and then we'll practice finding area. Okay, let's look at the first with me question. We are going to find the area of several different shapes here. When you show your work, it must look like mine. I am very, very particular about the work when it comes to geometry because it not only practices helping you memorize the formulas, but it also helps you stay organized the way we do in algebra. So the first thing you have to do every time you're finding area is identify what shape are we talking about. So when I take a look at this, my eyes are already looking at the fact that this is slanted, that they've added in a dotted line, and so I'm thinking this is a parallelogram. So the first thing we need to do is just write the formula. You must write the formula for all problems first. So we always start with A equals, and then for area of a parallelogram, of course, it's B times H. Okay, and now we're going to substitute in the information we know. So we don't know area yet. So we're going to keep A equals, and this is kind of cool because in the last chapter we weren't allowed to have equal signs, but now we are. We're finding area. So we're going to go ahead and substitute in what we know. So if I look at this parallelogram, find the base is 15. Remember, base is along the bottom, thinking of the basement. So we're going to substitute in a 15 for the base times, and now we need to find the height. Again, keep in mind, we cannot have this slanted line for the height. No slouching on our height. We need that nice line that meets the base at a right angle. And so this is where that dotted line got added in. We're going to use the 12 for our height. Okay, take a second and figure out the area, 15 times 12. Okay, I got 180, and we need to put a label on that. So we're going to put feet, and we're going to put a little 2 there showing it is feet squared. Now take a look at your work. You should have formula first, substitution second, the answer with a label third, and all lines of work always start with A equals. Okay, you're allowed to use equal signs in this chapter, so let's do it. All right, let's look at the second one. This time I'm looking at the shape and I'm identifying, okay, I see a 4-sided figure. I see right angles. So I know I'm either talking about a rectangle or a square. So I pay attention to my sides. They are different. So this must be a rectangle. So the formula I need to use if I peek up at the top of my notes is A equals length times width. You'll notice that we're going to put kind of a little hook at the bottom of the L so it doesn't look like a 1 like it does when we type it. So if I were you, I would definitely recommend doing that. Okay, so now we're going to substitute in our length and our width. So keeping in mind that length, of course, goes left to right. They start with an L, left to right. Our length in this picture is a 4. So let's substitute in the 4. And then our width, it goes up and down, and it is our 15. So we'll substitute in 15. So take a minute. What is 4 times 15? And we get A equals 60 feet squared. Again, we're going to pull the feet right out of the picture. We're going to add a little 2 to show it is area, feet squared. Take a look at your work. Formula first, substitution second, answer with a label, and of course, all lines start with A equals. Okay, let's go to the third one. Okay, so I'm looking at this shape trying to decide what it is. I see that it has 4 sides. I see that it has right angles. And I see that little marking we talked about showing that the sides are equivalent. So if I can see that those 2 sides are equivalent, I can assume that all 4 are equivalent. And they only labeled one side. So we can safely assume this is a square. So we're going to use A equals S squared. And there's only one number to substitute in. So A equals 10 squared. And hopefully remember how to use our exponents. 10 squared is not 20. It is 100. And we'll label meters squared. Again, formula first, substitution second, answer with a label. Put A equals in front of all lines. Okay, and then the last with me, I just wanted to show you that occasionally you might see a parallelogram where they put the dotted line outside the figure. And the only reason for that is to make it meet at a nice right angle. The only way to do that was to extend out the base and then add in the height. We still are going to use the base that is part of the figure. It's just we needed that nice right angle to become the base. So it is a parallelogram. So we'll use A equals B times H. And we're going to substitute in our base. Now here's where we got to pay attention. There is no number at the bottom, but we know the bottom is equivalent to that number at the top. Those sides are congruent. So we're going to substitute in a 10. And the height, of course, we want to use where it meets at a right angle, so it's going to be 12. We solve it out. Area equals 120 centimeters squared. Okay, there are 4 on your own questions. I would like you to do those on your own, but I want you to be very, very careful. Make sure that you have formula first, substitution second, answer with a label with A equals in front of all lines of work. And then I'd like you to pause this video. We'll share answers here once everybody's ready. Okay, I'm going to go ahead and share answers for the on your own questions. Hopefully you've paused and gone through those questions. Here is the first one. It is a square, so I used A equals S squared. Substituted in the 13 and got an answer of A equals 169 inches squared. For the second one, we have a parallelogram. So I'm using A equals base times height, the base being 12, and the height is the 3 because it meets at a nice right angle, and we end up with an area of 36 centimeters squared. For the third one, we have a parallelogram, and the parallelogram is base times height. This one looks a little funky because we have an extra side added out, and they didn't make it a dotted line. They actually made it red, although on your notes it's not red, sorry. But it is where they extended out the height, extended out the base, I'm sorry, to add in a height. So the base times height is 7 times 18, and we end up with an area of 126 inches squared. For the fourth one, we have A rectangle, it is a rectangle. I know when it's kind of turned like that, it might deceive you and make you think it's a parallelogram, but they put in a right angle there, so it is a rectangle. So I used area equals length times width, substitute in 10 times 5, and got an area of 50 meters squared. Okay, there were 2 left here, and I didn't put in my work for those, so we'll solve these out together. Skinny rectangle. Okay, so we'll do area equals length times width. We substitute in our length left to right is going to be 2 times our width is 14. And we end up with area equals 28 inches squared. And the last one, this is a square. I know that for a couple of reasons. I see the right angle. I see they've given us the markings showing those sides are equivalent. And because they only gave 1 dimension, we can safely assume that means they're telling us the other 3 sides are also 8 feet. So I'm going to use area equals s squared. Substitute in the 8 squared. And of course, please, 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 I hope you remembered this is 64, not 16. And we'll label feet squared. Okay, I'd like you to take a peek at your neighbor. Don't take their paper, just peek. Did their work for all 6 of these questions have formula first, substitution second, answer and label with A equals in front of all lines of work? If your neighbor is missing any of those things, make sure you let him or her know. If you are missing any of those things, make sure you fix it. Okay, if there are any questions, please make sure you ask before you move on to math time. Talk to each other, talk to the sub, work through any of these. As I said, though, your work must look like mine on your eye today, on your homework tonight, and I would suggest really working on memorizing those formulas. In fact, why don't you turn to your neighbor and tell them the formula for a parallelogram? Tell them the formula for a rectangle. And tell them the formula for a square. Okay, today's I is not written on the board, so I have it written here. If you need to keep your notes out for the formulas, go ahead and keep them out. If you think you know them, great, you can put your notes away. For today's I, please make sure you note that this is lesson 4.1, but it is not in our textbook. You need to make sure you get on Polaris only. You can see the pages and the problem numbers there. And then when you're finished, you need to go back to the selected answers on Polaris and grade that using that link. Please, let's pause the video on this screen so we can write down our I assignment and get started on math time. Have a good day.